Welcome. This is now the Honors Module 1 review solutions for the tests. This is the review packet. This is going to cover part 5, 6, 7, and 8. Alright, part 5, it says here, 8 sequence is given here. It asks us to write the recursive relationship for the sequence, explain how you determine your answer. To find the recursive, right, I have to first determine if this is geometric or arithmetic. So, test for the common difference. I saw there is no common difference. Then I test for the common ratio, and I see that it is equal to -4. Then because it is a common ratio, I realize it is geometric. Once I know that it is geometric, I just simply write the recursive formula for the geometric sequence, plug in the common ratio, which is -4, and I am simply done. Next, I get the explicit equation. I plug in the explicit equation. There's two forms. The one that uses the first term, which is f of 1, or use the zeroth term, which is f of 0. In our case, I have the first term here, which is 3, so I'm going to end up using this one. F of n is equal to the first term times r to the power t minus 1. So I plug in 3 here for the first term, okay, and I plug in here r, which is -4, which is what I determine here as the common ratio, and I am done at that point. Okay, good. Alright, let's look at part 6. Here it says to match each of the following sequence with its function. You can use, notice that you're not going to use all of the given functions. Right, so I have 1, 2, 3, 4, 5, 6 different functions with 4 sequences. Okay, I'm going to be displaying the answer here. I'm not going to be showing it in detail, but I'm going to show over the solution steps. Okay, first of all, again, you always want to check for the common ratio or the common difference. Second, determine if it's geometric or arithmetic. After, because if it's a common ratio, you find the geometric sequence. If it's common difference, you get the arithmetic. Okay. Once you have that, you simply get the formula, either the recursive or the explicit, and plug in the values to check. Okay. So the first one here, here's your solution. Right, it seems like it uses the recursive, and it is geometric. The second one, looks like it is arithmetic, and it also uses the recursive. The third one, it looks like that is geometric, and that looks like it's using the recursive. No, the explicit right there. And the next one, it looks like it is arithmetic, and looks like it's using the y equals mx plus b. Okay. Alright, let's look at part 7 now. Part 7. It says, Mr. S wrote 6 different situations that are shown in the answer choices below. Select all that can be modified as a linear equation. Just to let you know, a linear equation is like an arithmetic sequence, okay? It behaves the same exact way. Alright, so we are looking for things that have a common ratio or a consistent slope or a constant slope. Alright, so let's look at this, right? Because remember, what the linear equation and the arithmetic sequence have in common is both of them have a constant slope or a common difference. Alright, so let's look at the first one. Drive at 80 miles per hour, which is a constant slope, which is, okay, constant rate. So we call that valid. So that is a valid answer. Okay. Growth at 3% per year is not a constant slope, so that is wrong. So that is not a linear equation. Next, it grows 6 inches per year. Right? The tree grows 6 inches per year. Right? Per year, which is constant slope, so we could say that is a linear equation. A rate of 9.8 meters per second, which is acceleration, and that is also a constant slope. Decrease at 12% every single 7 minutes. Again, that is a percentage, so that is not a constant slope. Drop 10 points is a constant slope because it is what? 10 points per every single airplane thrown. Right? So that is also a linear equation because it has a constant slope. Right? Anything here that has a constant slope can be written as a linear equation. So the first one works, the third, fourth, and last one works as all as linear equations. Alright, let's look at the next one. We have the sequence of triangles. One triangle, right? Then something happens to the triangle, okay? So again, the best way you can approach this is that you can write out it in a table format. So the first one would term could have one triangle. The second term has 1, 2, 3, 4. The next one has 1, 2, 3, 4, 5, 6, 7 7 triangles. Okay. So here I could see that it can be modeled by the recursive equation because it is growing geometrically because there is a common ratio. Okay, it is growing 4. Okay, and 1 is the first term, so I plug it in here. So is Isaac correct? Yes or no? Do you think Isaac is wrong? Please give the correct recursive function. I would say that it is incorrect because the common difference should be 3. It should not be 4. Do you see from here to the second step, it's only 3 triangles that are growing. Next one, it's only 3 triangles that are growing. So the shape is only growing by 3 triangles each step. So it is geometric, not it is arithmetic, not geometric. Okay, here they think it's geometric, which is wrong. Okay, it is really arithmetic in our case. So f of n is equal to 3 plus your previous term, which be the recursive equation. Next, this would be the equivalent explicit equation. Your first term is 1, your common difference is 3. You could plug it into here. 1 plus your first term plus your common difference times your previous term. That would be the recursive, proper recursive. Sorry, this would be your proper explicit. Okay, good. Or you could write this into, you can't really put this into y equals mx plus b, but there you go. Alright. Alright, there you go. That is your part 8. Which covers part 2 covers 5, 6, 7, and 8. Yep.